Hi, my name is Jonathan. Welcome to Cisco SD WAN, deploying using enterprise certificate authorities. What we're going to do is we're going to tell you how to deploy the Cisco SD WAN controllers in the public or private cloud or any enterprise, as well as how a managed service provider scenario is set up and used to use an enterprise certificate authority. And after we're done with this, you should just be able to describe how those, what the requirements are and how to generate and verify those certificates. We're also going to do a quick overview of what certificates are and how they're generated. So let's talk about how we use them here. So for any cloud-based deployments or deployments where all devices have internet access, you can use the default CA infrastructure from DigiCert, which is built into all of the devices. This is the easiest way to use certificates, but it relies on an external certificate authority, DigiCert. If the network has no internet access for all devices, or if an enterprise or service provider prefers it, you can use a local CA instead. If enterprises or service providers already have a production level CA hierarchy, they're going to want to use that setup for the SD-WAN infrastructure as well. And this is easily possible. Before the deployment, it's recommended that we're going to test the compatibility with your enterprise CA. Most enterprises use a Microsoft Certificate Authority, which is supported by the Cisco SD-WAN solution. Other CA solutions may work, but you're going to have to test them first. Okay? Basically, if you're not familiar with how certificates work, it's basically similar to a passport in that the certificate contains information about the owner. In our case, also about a public key that the owner may use, and is signed by an authority. Passports are signed by governments. Certificates are signed by certificate authorities. You trust the passport because you trust the government agency that issued it. Likewise, you trust the certificate because you trust the certificate authority that signed it. A certificate basically states the following. The certificate authority signing this certificate attests that the public key listed in this certificate belongs to the node with the identification above. Any other node may use that certificate if that node trusts the same certificate authority. Pretty straightforward. So basically, a certificate installation is a two-step process. We're going to need to install get the root certificate, and then we're going to need to enroll and get their own certificate using a certificate signing request. Okay? Which basically says, here's my public key, here's who I am, and you send that to the certificate authority, and they append their public key to it, saying you're actually who you are. Okay? So in a certificate hierarchy, every node trusts the same certificate authority, root CA. All right? If I trust your root, I trust any certs that your root has issued, also known as, well, yours. The first step in the certificate installation process is for the nodes to get the root certificate. Basically, the root CA creates and issues a root CA certificate. All nodes in the network are required to, will require it in order to validate certificates. I trust the root CA, right? If I trust the root CA, again, I trust any certificate that the root CA signed. We're going to need to distribute that root CA certificate to all nodes by using secure copy protocol to copy that root cert to all the controllers, and then we install the root CA certificate on each node. Okay? The second step in the process is that every node in the network must perform the following steps. You're going to create an enrollment information, including your keys. This is also known as a certificate signing request. You may hear it also as a CSR. And then we're going to send the enrollment information, the CSR, to the root CA to sign it. On the CA, the enrollment information for each node must be verified to make sure no fake devices can enroll, and signed. This signature basically means that I, the certificate authority, attest you can trust this node certificate. It is a node of our domain. This attestation is stored in the root node certificate. Node certificates then contain only public information and can be distributed freely. The whole point of this is basically I share my public certificate. You use my public certificate to encrypt your data with your and then I use my private key to decrypt that data. In many cases, you're going to send your own certificate to peer nodes, and in an SD-WAN, certificates are distributed through the vSmart controllers. Consequently, each node has the root certificate of the CA and its own certificate. Again, nodes might receive other node certificates directly. The distribution method really doesn't matter. We all trust the same certificate authority that issued our certs, so we all also trust each other. Pretty straightforward. Now, before the two nodes can communicate, each node must possess the certificate of the peer node. The peer certificate was signed by the same root CA that the node has locally. Therefore, the node uses the root certificate to validate the signature of the peer certificate. If that signature is correct, the node uses the public key included in the peer certificate. Now both sides have a public key of their peer and can start a secure communication using this key material. Note, in the SD-WAN, vEdge routers receive all crypto information from vSmart controllers, so the exchange illustrated in the figure occurs between a vEdge and a vSmart, but not between vEdge routers directly. This is a control connection, not a data connection. Remember, only data connections occur between vEdge devices. Control connections occur between vEdge devices and vSmarts only. Okay? That way we're not having 500 vEdge devices trying to share and make tunnels with 499 other vEdge devices at the same time. Basically, then all the data would be consumed by just peer negotiations. Okay? We're going to go over at a high level how to set up a certificate authority. It's going to require some local configuration. Realistically, I generally leave this setting up of a certificate authority to your security professionals in your organization. Generally, setting up your own CA because you're deploying SD-WAN is going to make some people upset in your environment if you don't involve them. So basically, you're going to create a custom OpenSSL configuration file, specify paths for the new certificate, database, serial numbers, etc. Describe a path to the local private key, specify validity in days, specify a policy. So this local configuration is going to define how that information is structured, where the keys are, and so forth. The reason you shouldn't just randomly install your own certificate authority in your environment without notifying the rest of your environment is they may already have a certificate authority and they may get unhinged a little if another certificate authority comes up in the network. Okay? Because here's the thing, you could affect the security of the entire network if you misconfigure this. So involve them. Make new friends. So there's two distinct steps to create a new root CA. We need to create a key pair with the following command: OpenSSL generate RSE out CA key up here in the top. And then we're going to create a self-signed certificate by entering the information about the certificate. This is the certificate of the certificate authority signed by the CA, thus it's self-signed. The result is going to be this ca.cert, which is the CA root certificate that we're going to have to copy to all the controllers in the edge device. The days parameter sets the root CA validity to the desired length. The default is 30. I think that's a little short. The example here is created using OpenSSL. Other CAs are possible. If you're a Microsoft environment, you probably have a Microsoft certificate authority there. I'd probably get your root CA for your domain so that you're not creating a competing certificate authority. Just my advice. Your mileage may vary. So remember before we talked about the fact that vManage must be aware of the other controllers. Remember we told it about vBond, but we need to create those controllers inside vManage so vManage can manage them. Remember, we're going to be doing software updates from vManage, so vManage needs to be able to know about the other devices. So we're going to go to Administration, Settings, and we're going to click the controllers and add the vBond IP address and username and password. And the vSmart controllers are configured in the same way, except that you choose vSmart instead of vBond under Add Controller. Okay? And then we'll want to enroll the controllers with the certificate authority. You're going to have to generate the CSR. The certificate signing request, as we mentioned before, which contains all the node information and the public keys that goes into the certificate. Then we transmit that CSR to the certificate authority. Okay. Basically, we take that CSR, we get it over to the certificate authority. Some offline verification is required, such as CA operator calling engineer on site in order to validate the data. If this were a public certificate, they'd ask you to verify the fact that you own your domain, basically by adding a text entry in your DNS records. After that validation occurs, the actual certificate will be created as a PEM file, and that PEM is basically a base64 encoded version of the certificate. And then that PEM file is going to be brought back to vManage and uploaded there. Okay. For each controller, install the certificate. Just select a file under Configuration Certificates. Click the Controller tab. Click Install Certificate. A pop-up will pop up. And you can paste the certificate file or select a file for installation. By the way, it's going to be a text file. It's going to say .pem, but what it actually is, it's going to be a hex, essentially a dump of encrypted data, and that's your entire certificate data. You can actually just paste that into the field, or you can upload the file itself. And then click install. And you're going to do that for each of your controllers. So if you have 4 vSmarts, you're going to have to do it for all 4, etc. Okay? And then once you've started that, you can actually go, and I want to mention this separately as well. Anytime you do anything on vManage, it's generally going to create a task, and then you can navigate away, but the task will still be running. So you can actually go back there by clicking this icon up here for the task. It's already in red, so let's put it in peach as well, so it's multicolored. And then you can go back there and see the process of the task. All right, so here we have a success, so we know that this task was successful, and this log information down here will change for whatever the task may be, but if a task fails, it's going to tell you in great detail why. It may be because a variable was specified incorrectly or some other reason. But generally, this is going to be really useful troubleshooting information for anything you do that doesn't work. By the way, a lot of the information you're going to see here in this task output is remarkably good feedback for troubleshooting what occurs. Okay? So let's talk about VPN 0 again. We're going to talk about VPN 0 a lot in this course just because it's so important. After we set up all these controllers and before we go into normal operations, we're going to have to configure that tunnel interface on all controllers. Remember before we turned off this tunnel interface to complete the configuration. Okay? So we're going to actually have to turn this guy back on. Remember, all OMP tunnels, all of our overlay network is going to be established on this interface. Okay? It's always VPN 0. And also at the same time, when the tunnel interface is configured, no other protocols are going to be allowed on here, except explicitly allowed. And you'll see those in the configuration. You'll see allow protocol, etc. All right. And we'll also, because we're connecting to vBond, we'll also make sure that we're going to be encapsulation IPsec. So if we're encapsulation GRE, which was our other option, we won't be able to tunnel back to vBond. Okay. So then we'll want to make sure our control connections are actually up. So on the vManage dashboard, and if you see that little grid thing over here, all right, that'll bring us to the vManage dashboard, and it'll tell us if our connections to vSmart, vBond, and vManage are actually up and running. Ideally, we want to see green arrows upwards. If we have 2 vSmarts, one's up, one down, you'll see one with a green arrow and one with a red arrow pointing down. vEdge routers are going to be displayed as control up if they have all those required control channels to all vSmart controllers. Okay, so this is going to be your point. This is when you very first log in, this is what you're going to see on vManage, is this vManage dashboard, which will tell you which sites have full connectivity versus partial or none. You could have partial connectivity if you, let's say there's 2 vSmarts and you only have access to, it has only connectivity to 1, you don't have full tunnel connectivity, etc. Okay? All right. So as we stated, every element of the SD-WAN fabric is going to require a valid certificate in order to join that fabric. They can be signed publicly via Symantec, or you can use a local certificate authority. It's up to you. Generally, if you're using the Cisco public cloud or any other public cloud, you're going to just leave them with the DigiCert public certificate. No reason to reinvent a working wheel, especially if it's correctly rounded. And thank you very much for watching.